October 22nd, 2025, a date that will be remembered as the turning point of human technology. On this day, Google announced an achievement that scientists had once described as impossible. They officially reached verifiable quantum advantage, a milestone where quantum computers outperform even the most powerful classical supercomputers on Earth. But what happened wasn't just about faster processors or complex algorithms. It was about rewriting the very laws of physics we thought were unbreakable. Google's Willow quantum chip solved a problem that would take the best classical supercomputers longer than the age of the universe to complete. That's not an exaggeration. But the truly shocking part isn't just the computation itself, it's what they did next. Using the Willow chip, Google scientists managed to peer inside molecules in ways that were previously impossible. They shattered a 200-year-old principle of thermodynamics called the Carnot limit, which defined the maximum efficiency of heat engines. For 2 centuries, this law set the boundaries of how energy could be converted into work. But a team of researchers in Germany has now proven that quantum systems can surpass those classical efficiency limits. In essence, the universe just revealed it's been hiding a secret, one that allows energy and information to behave in ways we never thought possible. Think about that for a moment. Every machine we've built, from steam engines to smartphones, was designed under those old physical limits. Now those rules don't apply anymore at the quantum scale. Google's Willow chip performed over 1 trillion measurements, more than every quantum computer in history combined, and it did that in just weeks. Here's the pattern emerging from this revolution. First, we've achieved quantum error correction below threshold, meaning quantum computers can now fix their own mistakes faster than they make them. Imagine a car that automatically repairs itself while speeding at 200 miles per hour. Second, we're seeing quantum supremacy evolve into real-world application. Google's quantum echoes algorithm is already analyzing molecular structures that classical spectroscopy struggles to decode, breakthroughs that could transform drug discovery, materials science, and biology. Third, and most groundbreaking of all, scientists have found a way to convert quantum correlations themselves into usable energy. In other words, they're turning the strange quantum property of entanglement into a power source. This opens the door to molecular engines, medical nanobots, and atomic-scale machines that can assemble materials one atom at a time. This isn't a small improvement. It's a complete category shift. We're not talking 10% better performance. We're talking about breaking limits that were once thought to be fundamental to reality itself. Now let's talk about 2025, the year quantum technology went from fascinating experiment to world-changing reality. Google's Willow chip operates with a 99.97% fidelity on single-qubit gates and 99.88% on entangling gates. For context, that's like having a computer that makes only one error every 10,000 operations, at speeds measured in nanoseconds. Your laptop can't even come close to that accuracy. Their quantum echoes algorithm functions like a butterfly effect machine. They disturb one qubit, then reverse time, analyzing how that disturbance ripples across the entire system, revealing molecular structures invisible to any classical method. It's like building a ruler that can measure distances between atoms. And this isn't just Google. Around the world, universities are now demonstrating engines that surpass classical efficiency and quantum processors built specifically for chemistry simulations, drug development, and materials design. The timeline for practical quantum advantage has collapsed from someday to now. Here's what's truly at stake. Every pharmaceutical company, materials lab, and chemical manufacturer has always operated under classical limits. But those limits have just been obliterated. We're entering an age where new drugs will be discovered in months, not decades. Materials with unimaginable properties will emerge. Catalysts once thought impossible will suddenly work. And this isn't stopping at chemistry. Google's roadmap is clear. They're moving toward fault-tolerant quantum computing, the holy grail that will make quantum processors as reliable as classical ones. They've already achieved 2 massive milestones. In 2019, beyond classical computation. In 2023, a prototype for quantum error correction. And now, with Willow, 2024, they've demonstrated real below-threshold correction. Each leap brings us closer to a world where quantum computers don't just solve specific problems, they redefine computation itself. Here's the wild part. Every quantum breakthrough accelerates the next one. It took 40 years to stabilize superconducting qubits. It took 4 years to go from quantum supremacy to real applications. The next breakthrough? It'll happen even faster. This is exponential growth, in a field where exponential growth was once thought impossible. So what does this mean for industries? Drug discovery that once took 15 years and billions of dollars could now happen in months. Personalized medicine could adapt treatments to your unique DNA in real time. Material science could create room-temperature superconductors, ultra-efficient batteries, and elements that don't exist in nature. Finance and energy systems could model global variables instantly, optimizing everything from markets to climate control. And yes, cryptography will be both revolutionized and threatened. Current encryption systems will break, but new unbreakable quantum encryption will take their place. The race has already begun to make our entire digital infrastructure quantum-proof before these machines become strong enough to crack everything. And then there's AI, the mind-bending connection. AI is being used to design better quantum computers, while quantum computers are being built to accelerate AI itself. This creates a self-reinforcing feedback loop that could redefine intelligence. When quantum computers can run quantum machine learning algorithms, we'll see a new kind of AI, one that can think in superposition, analyze infinite possibilities simultaneously, and learn in ways that defy classical logic. Let's look at the timeline ahead. 2025. Quantum advantage is verified in real-world use. 2026 to 2027. Fully fault-tolerant systems arrive. 2028. Commercial quantum services go mainstream. 2030. Quantum classical hybrid systems become standard in research and industry. The companies preparing today, hiring quantum engineers, exploring applications, will dominate tomorrow. But this revolution comes with a dark side. The same quantum systems that can cure diseases can also design bioweapons. The same algorithms that optimize clean energy can breach global banking systems. The gap between those who have quantum power and those who don't could become a genuine security threat. Quantum isn't just a tool, it's a weapon, a cure, and a paradigm shift all at once. So what should you do? If you're a business leader, start building quantum literacy in your teams. If you're a researcher, quantum mechanics will open frontiers you couldn't even study before. If you're a student, quantum skills will be as vital as programming. And if you're simply someone trying to stay informed, understand that quantum isn't the future anymore. It's the present. Google's team has shared their findings openly because they know true progress doesn't come from secrecy, but from collaboration. The power of quantum lies not in owning it, but in using it to accelerate global discovery. We are entering an age where those who can think quantumly, those who can embrace uncertainty, entanglement, and multidimensional thinking will lead the next generation of innovation. Quantum computing isn't just another invention. It's the foundation that will amplify every other technology, from AI to medicine to clean energy. Within a decade, quantum-powered discoveries will reshape civilization itself. We're not ready, but it's coming anyway. The only question is, will you ride the wave or will you be swept away by it? Let's embrace this quantum-powered transformation together, because this, right now, is the most important technological shift of our lifetime.